In this video, I'd like to introduce some properties of projectile motion and solve a simple projectile problem where an object is launched horizontally off a cliff. So first, what is a projectile? A projectile is an object that is flying through the air acted only upon gravity. Now, in truth, projectiles are also experiencing forces like air resistance and the effects of wind, those kinds of things, but until we're ready to handle more complex math, we'll assume air resistance is small enough to ignore. So when an object is flying through the air, it is only experiencing the acceleration due to gravity. So if I have an object, let's say a ball rolls off a table or something like that, or something rolls off a cliff. When it begins moving, after it leaves the ledge, it begins accelerating downward, and it will move in some kind of a parabolic path. Now, if I analyze this parabolic motion in two directions, since the acceleration is only in the y direction, the horizontal component of velocity, which I can call Vx, is constant. It doesn't change. There's no force happening in the x direction, so there's no acceleration in the x direction. However, although it doesn't start with any initial velocity in the y direction, once it has left this ledge, it begins falling faster and faster and faster, gaining vertical velocity, which we can call Vy. Vx is constant, Vy is changing. And how much does it change? Vy will change by g. It will gain 9.8 meters per second squared, or rather meters per second every second. And since it's happening down, I'm going to call that negative 9.8. Okay? If I want to analyze a situation like this, maybe I'll begin with some initial parameters. Let's say that maybe it's a cliff and it's 45 meters high. And let's say this ball rolls off the cliff with an initial velocity of 10 meters per second. If I would like to find how far it goes, I can call that distance x, how far from the base of the cliff. I can begin by writing out some useful equations. In the x direction, because there is no acceleration, I can use my kinematics equation for the distance traveled equaling velocity times time. However, since the velocity that I'm interested in here is just the x part, I'm going to call it Vx, the velocity in the x direction. And that's it. In the y direction, I'm going to write a kinematics equation that the height that it has, which I'll call y, is going to equal the height that it started with plus any height that it gains by virtue of its initial velocity in the y direction plus any height that changes as a result of acceleration. Okay, so some terms here. This is the initial height, or y naught. This is the initial velocity in the y direction, called v naught y. And this acceleration, since it's a projectile, the only acceleration it experiences is g, or negative 9.8 meters per second squared. So I can begin putting in information. I want to know how far it goes horizontally. That's x. I know that Vx is unchanging. That's 10. But I don't know the time. How long will it take for this object to land? Well, a classic problem in projectiles would be the shot versus dropped object. If this thing rolled off at 10 meters per second, it would take some time to land. But even if it were dropped straight down, it would take the same amount of time to land. So I'm going to go into the y direction here, and I'm going to put in my parameters. The time that I'm interested in is when the object reaches the ground, which means that the height will be 0. What height does it begin with? It begins with 45 meters. What velocity does it have at the beginning in the y direction. This one doesn't have any initial velocity in the y direction. That is simply 0. And I have 1/2 negative 9.8 t squared. Okay, I can solve this. There's a lot of different ways to solve this. But what I'm going to do is subtract 45 from both sides. I'll take half of negative 9.8. That gives me negative 4.9 t squared. Okay, so solving this, I can obviously a negative drops out. And I take the square root of my answer and I get about 3. So it's going to take about 3 seconds for this object to land. Well, if it takes 3 objects to land, if it takes 3 seconds to land, then it's going to be flying horizontally for 3 seconds. So this object travels a distance of 30 meters. It's just that simple.